Good morning, students. Today we will discuss some problem related to determinant. There are different types of problem. We will try to solve 3 to 4 types today. First question is determinant a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c, and 3a, 6a plus 3b, 10a, 6b plus 6b plus 3c is equal to a cube. Particularly in problem of determinants, we will get problem just to prove when you can see the result you have to reach. After expanding determinant, you have to reach the result a cube. But it will be mentioned that you have to use property. Property, the most important property we have to use that a constant multiple of a particular row you can add to any other row, or a constant multiple of a particular column you can add to any other column, the result of the determinant will not change. So, and all other properties are also important, but most useful property is that property I have discussed. Now here, when we expand a determinant, we expand along a particular row or a particular column. We will deal with 3 by 3 order determinant. So out of these three terms, if we get a common factor or maximum number of zeros in that particular row or particular column, then it will be easy to expand the determinant. So our target will be to get a common factor from a particular row or particular column, or to get maximum zeros in a particular row or particular column. So here, if we use the operation that R2 is R2 minus 2R1, mean if we multiply the first row by 2 and subtract from the second row, that element A21 will be 0. And if we do another operation, R3 is R3 minus 3R1, then the element just below it will be again 0. Maximum 2 operations you can apply this type of operation. Suppose a constant multiple of a particular row when it is added or subtracted from any other row, you can use maximum 2. So finally you are getting the determinant a plus b plus c, 0, a, 2a plus b, 0, 3a, 7a plus 3b. Now if I expand along the first column, a into its minor, that is a, 2a plus b, 3a, 7a plus 3b, and other two elements, which is 0 into something plus 0 into something. That's why we have not written it. So after that, if we do again another operation, 3 multiple of first row is subtracted from the second row, then it will be again another 0. Multiply the first row by 3 and subtract from the second row. So R2 is R2 minus 3R1. So you will get A, 2A plus B, 0 and A. Now after this, there is no way other than to expand it. So you will expand it, you will get a into a square minus 0 is equal to a cube. Now let us consider another problem here. Example 2, we have discussed. Prove that the determinant, first row x, y, z, second row x square, y square, z square, third row x q, y q, z q is equal to x, y, z into x minus y into y minus z into z minus x. Here if you see the right hand side, the factors of this determinant are x minus y, y minus z and z minus x. So our target to get the factor x minus y or y minus z or z minus x in a particular row or particular column. So remember, our result is xyz into x minus y into y minus z into z minus x. If you see carefully, the first column has a common factor x and second column has another common factor y, and third column has also a common factor z. Taking these three common factors out of the determinant, we get xyz into the determinant 1 1 1 xyz x square y square z square. So in the first row we are getting 1 1 1. So operations are also written in this way, that c1 is 1 by x into c1, c2 is 1 by 1 into c2, c3 is 1 by z into c3. Here you can say three operations are applied, but remember, it is not that property where constant multiple of a particular row is added or subtracted to any other row. That property can't be applied more than twice in a particular step. So now if we apply c1 is c1 minus c3, is c1 is subtracted, c3 is subtracted from the c1, or you can say minus 1 multiple of c3 is added to c1. You can say in this way also. So another operation we have also applied, c2 is c2 minus c3. Then we are getting first row 0 0 1, second row x minus z, x square minus z square, and second row, second column 0 y minus z, y square minus z square, and third column is as it is because there is no change in there. So 1 z z square. Now if I expand along the first row, you will get 0 into something minus 0 into something plus 1 into a determinant which is minor of that, that is x minus z, y minus z, x square minus z square, y square minus z square. So first column has a common factor x minus z, second column has another factor y minus z. Taking these two factors out of this determinant, you will get 1 1 x plus z, y plus z. Again, if I apply c1 is c1 minus c2, then you will get 0 x minus y, 1 y plus z. Now you can expand it because there is no way to do any other operation. So that will be minus 1 into x minus y. So you will get x y z, x minus y, y minus z, z minus x. Okay. Another problem here, example number 3, which is a, b minus c, c plus b, a plus c, b, c minus a minus b, a plus b, c, which is equal to a plus b plus c into a square plus b square plus c square. You have to prove it. This is another type of problem where we multiply c1 by a square, c1 by a, c2 by b, and c3 by c. So total multiplication is a into b into c. So we have to divide by ABC. So that's why it is written 1 by ABC, and first column is multiplied by a, so it will be a square ac plus a square minus ab, and similarly second column will be b square minus bc, b square, ab plus b square, and third column is c square plus bc, c square minus ac, and c square. Why have we done this? If you see clearly that if we apply c1 is c1 plus c2 plus c3, actually two operations done together. First, if you can say c1 is added to c2, the next operation is then added to c3. So we have written simultaneously c1 is c1 plus c2 plus c3, means all three columns are added and posted at c1. So c1 will be a square plus b square plus c square, a square plus b square plus c square, a square plus b square plus c square. And other two columns remain same. So a square plus b square plus c square is a common factor in first column, and If we bring B from the second column and C from the third column, so BC will also come out, which will be cancelled, and only A will be remaining in the denominator, and it will be A square plus B square plus C square by A, and first column will be 1, 1, 1, second column will be B minus C, B, A plus B, and third column will be C plus B, C minus A, C. An operation also written C2 as 1 by B into C2, C3 is 1 by C into C3. Now if I apply R1 is R1 minus R3 and R2 is R2 minus R3, then you will get 0, 0, 1, first column, minus of A plus C, minus A plus B, and B minus A, C. So if we expand along the first column, you will get A square plus B square plus C square divided by A into 1 into its minus. Minor is minus of A plus C minus A, B minus A, and which will be A into A plus C plus AB, and A will be common, so it will be cancelled, and your result will be A square plus B square plus C square into A plus B plus C. So that's our result. And some other problem also given here, 4 and 5. You will try to understand. If not, we will discuss again in the next class. Thank you.